Hey there. If you're new, welcome to the channel. If you found your way back, then I'm really happy to see you again. Today we are continuing on our document object model lessons, and we're actually going to be building out our complete own model of the document object model today. If you missed the last video, you can go back and check that out, where we kind of go through what the document model is, why it's useful, how you can use it, and give kind of an overview and entry into this topic. Today we'll go a little bit deeper, a little bit more advanced. Some of the topics or some of the things we're gonna go through might be a little too advanced, but just don't get too lost in the details. The important part is not to figure out everything that's going on with the code in this lesson, but grasping the overall concept and getting why this is important, why it's important to learn this API, and what does it mean for you as a developer working with JavaScript. All right, so let's just go ahead and get started. And what we'll do is we'll open up Visual Studio Code. And I have here a index.html file and I have an index.js file. So we have a class here called output, or a div with the class called output, and that's going to be our root element. And what we are going to do is we're going to build a data representation of the document object model. And we are going to render our model to the screen. So what we'll do is we'll go to index.js. And just as a side note, we have the script linked up here. So we can head right over to index.js and we can get started. And the first thing we need is a class called node. And that's going to be that's going to have a constructor, and we will accept the tag as the only argument. So we will put up this dot tag equals tag, and then we'll say this text content equals empty string, and then we'll say this children equals empty array, and we'll say this properties, or actually we'll skip that one. We'll say this class list equals new class list. Oops. And we haven't made this yet, so what we'll do is we'll make a new class here called last list, and it's going to have a constructor as well, and we'll say self, not self, this dot classes equals empty array. All right, and then we'll add two methods here. So one will be add, and we'll say this classes push, and we'll accept the class name. And then we'll add a remove, and we'll say class name. And what we'll do is we'll say this classes equals this classes. Oops. So this dot classes equals this classes dot filter, and we'll take the item and we'll match on the class name, and we'll return every item that doesn't match this class name that's passed in. All right, so back to the node. What we want here is a method called append child, and that's going to take another node. So this node can have children, and they will be of the same type. So let's go ahead and say this children push, and we'll push the node. All right, so does this look familiar at all? Let's see. So let's say const container, and we'll say new node, we'll say div, and let's go ahead and log that out. And then let's go ahead and say container class list add my class. And let's go back to our browser. We'll open up the console here. And now you can see we have a node. The tag is div. And it has a class list, which has a classes array with my class in it. And this is exactly, or well, not exactly, we're missing some of it, but it's similar to what you would get if you did container equals document create element div. All right, you would have the same API to work with. All right, so we're trying to mimic that a little bit here. So now that we have that in place, what we want to do is we want to create our DOM class. So let's go ahead and say class DOM, and we'll say constructor this nodes equals nodes, and we'll accept that as a parameter when we instantiate. So we've talked about having an entry point, and this node is going to be our entry point, and then we'll add the children on to that node. And then what we'll do is when we create our DOM, we'll pass this node as the first node, okay? So we'll do const my DOM, and we'll say new DOM, and we'll pass the container here as the node. So if we console log my DOM, and let's see what we get in the console. So now we have a class of DOM, and it has a node, and the node has no children for now. That's fine. And I think what we'll do is we'll add a couple of children here, just to get something more to work with. And we'll do that by going, let's create a header, and that's going to be an h1 tag. And we'll say header text content equals my website, for example. And then let's do a description container, and we'll say new node div, and we'll create a description, and that's going to be a new node p, which is a paragraph, and we'll give that description a class as well, my paragraph class. And we'll say container append child header, and we'll say container append child description container. And we need to add the description container append child description. Okay, so we're working with the same way we would if we were using the real DOM. And we're using the method that we implemented on this node, which is basically just adding children to this array. And the children in this instance are of the type node, okay? So let's see what we have to work with if we open up our... Oh, we need to log that out. So console log my DOM. And I'll blow this up a little bit just in case it's too small. And we'll go through just so you can see what's been written if you missed it. So yeah, Let's go ahead and check out our console. If we refresh, now we have the DOM, and we have nodes, and we have children inside of here, and they have their own children as well. So it's kind of going down in a tree. So it's a tree-like structure here. And if you don't know what a tree is, basically, it's a parent-children relationship, and a parent can have many children, and it's kind of like the branches of a tree, where the parent is the main branch, and then you can have smaller branches going out from that branch, and those can have smaller branches again, and you can see how that can go on for a while, and that's why we call it a tree. Anyway, small computer science detour right there. Let's go ahead and get back to the DOM. So what we want to do here is we want to add some of the functionality that the real DOM has. So, for example, the real DOM has a method called query selector, and query selector will allow you to search the entire DOM for a CSS selector or a tag selector. So what we want to do is we want to create this as well, so we can retrieve our elements and modify them. So let's go ahead and implement that here. And what we need to do is we need to create a recursive method. So the first node that we want to perform this on is going to be the parent, or the root node here. So remember, the root node is the first node we made, the container, and it has a lot of children under it. And those have a lot of children again, or not a lot, but a few. And so we need to search all of those layers in order to search our entire data structure. So that means that we need to do something like this, where we say we get the current node, and then we want to find a node which is going to be returned from another method that we need to create. So we'll call that query selector internal, and we'll pass the selector and the current node. And then we'll return the node once we find it, and we need to accept the selector here. All right, so the selector, that will be a CSS selector, so something like my class, and I want to implement in the real query selector, you put a dot in front, but I won't do that right here just because I'm going to keep this as short as possible. But we'll be able to search the my class string and the tag. So if we do something like this, that's going to work as well. But let's go ahead and implement this internal method here. So query selector internal, and I'm actually going to prefix it with a underscore, which is quite a common way to denote internal methods in JavaScript when you don't have something like TypeScript to help you define what should be private or public. So we're going to accept the selector here and the node. And what we want to do is want to check if the node.tag equals the selector. So if we have an object that looks like tag h1, and we have a selector that is h1, then we want to return this node, because we only want to return the first instance we find. So we're gonna go ahead and return the node in that case, and then we'll create a variable called found, and we'll go ahead and we'll check if the node class list classes.length is greater than 0. So if we have any classes, remember we created a class list here, and it has this property. And if we have any classes, we want to check the classes of this node as well to see if they match. So if we're searching for, let's say, my class, then we want to check if that exists in this array. So if we have anything in it, we are going to do node class list classes for each, and we'll say class name, and if class name equals selector, oops, then what we'll do is we'll set found to be equal to the node, and then if we found it, we'll return the node. Okay, but we're not done yet, because we know that our nodes can have children. So in order for this to work properly, we need to search the children as well. And that's where the recursiveness comes in. The recursiveness just means that we are calling this function again with a child. So we're calling the function within the function. And this takes a little bit of time to wrap your head around. So I don't want you to worry about it right now. Obviously, if you're at that stage in your programming knowledge, then feel free to kind of dive deep into this and get into it. But what we'll do is we'll create a for loop here, and we'll say as long as I is less than or equal to node.children.length, we want to run this loop, and we'll say found equals this query selector internal, so this method here, and we'll say selector, which is not going to change, that's always going to be the same, but we'll say node.children.I here. So that just means that we're looping over the children. Every single one of the children we are passing to this method, and we're trying to see, well, do any of them match the selector? And if they do, we know that we are going to return it here. So we'll set found to be true here if that's the case. And that means that we can go ahead and do if found, return found down here as well. So let's make sure that this is working. We are going to try to find this class right here. So let's say paragraph equals my DOM dot query selector, and we'll search for this class and we'll log it out. Oops, can't type today. All right, so let's head over to our editor or browser, and we'll hit refresh. And cannot read property tag of undefined. Okay, so let's fix that. We'll go back to our editor, and I think we need a couple of checks here. So if this node's children.length is 0, let's return. And if node children length greater than 0, we will perform this operation. All right, let's go back to the browser, hit refresh, and now you can see we found our paragraph here. So now we can work with that paragraph. We can do paragraph text content hello, and if we hit refresh, that's going to update this node. All right, so that's good. Now we can retrieve nodes from our internal DOM data structure. The next thing we want to do is we actually want to render this DOM out as HTML. So we want to transform our internal data structure into HTML. So what we'll do is we'll add a new method to our DOM. And that's going to be after this one. We'll create a method called render nodes as HTML. And we'll create two helper methods, which will be render nodes as HTML internal. And that's going to be, we're going to do this recursively again. So this is going to be our entry method. The one will expose out the render nodes as HTML. And this will be our internal method. So in render nodes as HTML, we are going to get the current node, which is going to be this nodes. And we'll say root true. So we're just spreading that here, making a copy of this object and then adding a property to it. And we'll do output string is going to be empty string. And we'll create a stack, which is basically just an array. And we'll add this current node into it. And then we will create our output, which is going to be the result of calling this render HTML or render nodes as HTML internal, and it will accept the current node, the stack, and the output string. And let's go ahead and save that. And finally, we'll return the output string out once we've finished this method here and built out the HTML. So let's see here. We'll go ahead and actually we'll create a few more helper classes or helper methods here. So what we want to do is basically want to take the node and we want to create the text representation of it. So if we have a node like tag h1 and class list, basically classes my class. So if this is the object representation, I want to create this string. And let's say it has a text content. Hello world. So then I want this to be the representation. All right. So that's what I want to do. I want to take what I have as data and I want to transform that to a string. And in order to get the structure right, we need to use this stack because what we want to do is we want to make sure that when we are at the current node, we are just adding the beginnings of the tag. And we'll see that in a second. Let me just create these helper methods. So create HTML open string from node. And that's going to be output equals. We'll accept the node as the parameter here. And we'll say node.tag. So that'll take the tag and it will put a bracket in front of it. And then we'll create a empty classes variable, and we'll check the node class list classes length. And if it's greater than 0, we'll do classes equals and space class, and we are doing string interpolation here. That's why we're using these backticks. So what we want to do is we want to say classes node class list join and empty string. And then we'll say output. And we can actually just do this directly. We don't need to have that here. So let's go ahead and do this. And then we'll return the output here. And we'll put on the closing bracket. So that's gonna give us the opening bracket. So something like, if we go back to the example we had above, it will be like this part right here. And we can't really add this closing bracket here because we don't know what kind of children this node may have, right? Because it may have children and they're gonna live inside of here. So how do we solve that? Well, that's what we are doing with this stack. And we'll see that when we implement this render nodes as HTML internal. For now, let's create the HTML close string from node, and it's going to take a node parameter, and that's just going to return the closing tag. So node tag. Okay, so now we have those two helper methods. We might also want to do, let's see. We'll get to it. Let's focus on this method here right now. So what we want to do here is we want to accept the three arguments that we're passing in here. So the current node, the stack, and the output string. So if we have a stack and its length is 0, we want to return the output. And we'll just call this output. And then we added the root property to the current node. So that's the first node. And we'll do if node is not root. So if it doesn't have the root property, which none of the other nodes have, then we want to push those nodes onto the stack. And we're doing that because we are adding the current node outside here into the stack, into this array. But we are checking here if the array is empty, so we can't pass in an empty array. That's why we're doing this. Otherwise, we'd get into this function and it would just return without doing anything, and that's not what we want. We wanted to start adding the nodes to the array, and you'll see why in a second. So once we have a node, we want to create an starting output. So we want to use the node and use this create HTML open string and pass that in. So that's going to give us the starting tag, right? So the starting HTML tag. And then what we want to do after that is we want to check if this node has any children. So let's go ahead and say node children.length greater than 0. And if it does, we want to do node children for each. And then we'll take each child, which is a node itself, and we'll say output equals this render nodes as HTML internal. And we'll pass in the child, the stack, and the outputs. So for each child, we are passing in the child node, passing in the stack, which is the array basically, and we're passing in the output string as it currently is. And then we are reassigning the output string, because what's going to happen is we're going to dive into this method again, and it's going to build out the entire string and add on anything from its children again. And we don't want that to happen for each time, so we are rewriting the string here. And once that's done, once we have done that for each child, what we want to do is want to say pop. So we want to take a node off the stack, and we want to say output plus equals this create HTML close string from node, and we pass in the popped node. And then finally, we return the output. Okay. And I know that's a lot to take in, and don't worry too much about it for now. What matters is the end result and understanding the transformation from data to a string and how you're kind of using the data to build our HTML, right? So that's what the browser does. And that's what we've been doing here, just trying to build that transformation and showing you how it's done behind the scenes. And what we'll do right now is we're gonna go ahead and test this out, make sure that we can render our DOM as HTML. So we'll do my DOM render as HTML, and fingers crossed that we can refresh here and we get the right result. So we get, yeah, that's correct, because node class list join, that's going to be classes. Thank you very much. Let's see. And there we go. We have our HTML representation. And you can see that we have the classes, we have the divs, we have the correct structure. And we are missing the text content. And we could actually put that on as well. So let text content equals node text content, or text content or empty string, and we could put that in here as well. Not there, but here. And you can see that now we have the text content of the h1 tag here as well. So let's go ahead and just add this to the page here, just so we can see what we're working with, and use the real DOM instead of the fake one that we've created. So we'll go ahead and say root element equals document query selector. Let's see. What did I call the element? So it's the class of output. And then I want to create a code element. Document create element code. And we want to go ahead and create a pre tag. Document create element pre, and we'll say pre text content equals my DOM render nodes as HTML. And then we'll say code and child pre. And we'll say root element append child code. And let's do code class list add. Yeah, let's say code. And we'll add a code class here. Background color F1, 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 adding 1 rem. Actually, let's make this white. And if we hit refresh, now we have our HTML from our fake DOM rendered to the screen here. Right, so I think that's it. Now we have the ability to create a data representation of the document. and transform that back into HTML from our data structure. And I think, you know, if you follow this along, hopefully now you have a good grasp of the document object model and how it kind of works behind the scenes. And once you spend time with it and just let this concept sink in, you'll see how powerful it is. And it's basically the entire baseline, this and doing Ajax calls. It's the entire baseline for doing single page applications. And I fundamentally believe that understanding this at the core level really just raises your knowledge, or raises your competence as a developer by a lot. So hopefully you enjoyed this video. If you did, please leave a like and hit the subscribe button if you want to know when I post more content. And if you didn't like it, you can leave a dislike and let me know what I could improve. Anyways, thanks for tuning in, and I'll see you in the next video.